Hello friends, welcome to follow up. Let's have a look at problem 2709, greatest common divisor traversal. This problem is marked hard by leetcode. Actually, it's a very routine problem if we analyze it carefully. So this problem is nothing but finding the connected components for the corresponding graph. So in this video, we're going to explain a solution based on union find. So in this problem, the primes got involved. So we are also write a utility function to get the prime decomposition for a given integer. So here the problem statement is the following. So we are given a zero-indexed integer array called nums, and we are allowed to traverse between two indices I and j if the corresponding elements as the two indices have GCD greater than 1. So here GCD is the greatest common divisor. So our task is to determine if for every pair of indices I and j, there exists a sequence of traversals that can take us from I to j. So in other words, if there is a path between I and j, or if they are in the same connected component. So if we can do this for every pair of indices, it's actually corresponding to the fact that these indices are in the same connected component, right? So here the return is a boolean, right? So there are three examples. So the first example and the third example the returns are true, and the second one is false. So here in the second one, we can traverse between index 0 and 1. However, we cannot arrive at 5 from either 1 or 2, right? So here the constraints are the following. First, the length of this list is bounded above by 10 to the power 5. So this number basically defines the problem size here. And the elements are positive, and because it's bounded below by 1, and bounded above by 10 to the power 5. So with that said, let's look at the problem analysis. So here the problem nature, as we mentioned, so is to determine if the corresponding graph is singly connected. So actually you can also look at problem 952. Essentially the two problems are the same. So when we talk about connected components, so typically there are two types of methods. So one is traversal, the other is union find. So here we are going to use union find. We find that union find is very natural for this problem. So here I'm going to use example 3 to fix the idea. So the big picture of this coding task. So here first I'm going to establish a prime and indices map. So here the prime means the primes involved in the numbers in the list, and the indices means if the corresponding number at those indices contain the prime p as a factor. So let's look at example 3. So here at index 0 we have 4. So its prime decomposition is 2 times 2. And for index 1, so this 3. 3 is 3 itself, right? For the number at index 2, so we have 12. 12 is 2 times 2 times 3. So in other words, the prime factors are 2 and 3. For the fourth element at index 3, so it's 8. 8 is 2 to the power 3, so the prime factor is 2. So the primes involved are 2 and 3, right? So we can make a dictionary, right? So the k will be the prime factors, and the value is the corresponding index list. For example, for prime factor 2, so it appears in 4 and 12 and 8, corresponding to index 0, 2, 3. So we have this list of indices as value. Then for the prime factor 3, so we have here it appears here, and also it appears here. So it corresponding to indices 1, 2. So the indices with corresponding to the same prime factors means that they contain the corresponding numbers contain this prime factor. So you can travel among them, right? So in other words, 0, 2, and 3 are in the same cluster. So if we look at this list, it means that 1 and 2 are also in the same cluster. So 0, 1, 2, and 3 are in the same cluster. In other words, the graph is singly connected. Therefore, for this example, we return true. So this is the main logic, and actually it's very natural and very straightforward in such a sense. So you do decomposition and you get the prime factors, and then for the prime factors appeared, you associate with the corresponding indices, right? Then you check if the indices forms or are in the same connected components. So with that said, we are ready to do the coding. So as we mentioned, we are going to implement a function, utility function. So this function, so given a number, so we are going to find its prime decomposition, right? So this is actually a very standard task, right? So here we can either find all the prime factors like 2, 2, 3, or we can just find 2 and 3. So in this problem, we just need to use a set. We don't count the occurrences of the prime numbers. So we have a result, right? So then let's first get factor 2. So if n modulo 2 equals 0, right? So we're going to do this add 2, right? And then n modulo 2, right? So this is one case. So next, basically, we are going to check for I in range. So from 3 to integer, so n square root. So here are plus 1, right? And then we're going to do another while if this n modulo I equals 0. And then we're going to do result at I, right? Then we do interdivision. So afterwards, if n is greater than 1, so we are going to do this result at m. So otherwise, we just directly return the result. So here, if you change this set to be a list, and then you change this add to be append, right? You are going to get all the prime factors with multiplicity. But here, we are using a set. We are going to get just the prime factor set. Like 12, we are going to get 2 and 3. So this is a utility function. Actually, this is a separate leetcode problem, right? So this function actually is very useful for address a number of other leetcode problems involving prime factors. So now let's look at the problem logic. So first, I'm going to get prime to indices. So we are going to use collections default dictionary, right? So here we are going to put it in a list. And the purpose of this one is that we get the prime factors appeared for the numbers in this list nums, and then we associate the corresponding indices to that prime number. So this is easy to do. So for I and y in enumerate nums. So here we are retrieving the indices, right? So then what we are going to do, primes, basically let's get self primes. So we get the prime decomposition. So this is the set. We are going to check what's the prime factors appeared in the number. And then because each prime number, so this y contains that prime number, we are going to add to the corresponding the dictionary value. So basically for p in primes, and then what we are going to do, we are going to do prime to indices. So we are going to append this corresponding index, right? So this way, we could get all the prime factors, like in this example is 2 and 3, and then the associated indices. The associated indices mean that for the corresponding element at those indices, it contains this prime factor. So with that said, basically we can run the union find trick. So here, let me first get the length of this one so that I can find initialize the root at the rack. So here I'm going to do this. So here root originally, so it's num steps for I in range m, and then so here rack is for 1 for I in range m. So this is very routine, right? Then we're going to define a union and find method respectively, and then we're going to encode the problem logic. So let me first define the find method, which is very routine, right? So I'm going to initialize a result variable, and then we check if result does not equal to root result. Then we're going to do this, right? We are going to retrieve along the chain. So then we return a result. So in order to accelerate, we can use path compression. So let's do here. Result equals root result. Right. Let me copy this part and then put it here, and then I apply root. So this actually is a path compression stage. So later is convenience for check delegate or representation of a cluster. So this is the find method, right? And then let's define the union method. So we are going to accept 2 arguments, and we check if they are in the same cluster or not. If not, we are going to join them. So first we are going to get the root, right? Root I, root G equals find I, find G, right? So if root I equals to root G, so we do nothing. Otherwise, so we are going to check the rack. If rack of root I is no less than that of root G, so we are going to set the root of root G to be root I. So here is a tuple. So here's root G, and then we are going to increment the rack of root I by that of root G. So change it to be plus, right? So otherwise, so if this relation is strictly less, so we are going to do in the reverse direction, right? So we are going to set the root of root I to be root G, and then we increment the rack of root G by that of root I. So this is the union operation. So this is just some preparations, right? So next, let's look at the problem logic. So for cluster, or for each primary index, is corresponding to a cluster. So in prime to indices values, so we only care about these values. And then let's pick one of the elements first. So cluster, right? This is 0, and then all the indices in the cluster is connected to this one. For example, you can choose any one, so we can union them. So for J in cluster, so 1 up to at the end, and then we just do the union, right? IJ, right? And then so this is the problem logic. And finally, what we are left is to find if all the indices from 0 to n-1 are in the same cluster. In other words, if they have the same root. So we're going to return this one. Let's check. First use set comprehension. So for I in range, right? So we found there are roots, and then we check the length, and we test if it's 1. If it's 1, it means that all the indices are in the same cluster, means that we can traverse among them, or in particular, we can, for any pair of indices, we can do the traversal in the sense of this problem, right? So this piece of code forms a solution to the current problem. So before we make any further comments, let's first do a test. Yeah, it passes the first example here. now let's look at the generic case. Yeah, it passes all the cases, but it takes some time. So here, let me give a quick summary. So in this problem, we used union find to solve or address the logic. So there are basically several ingredients. The first one is that we need to be able to decompose a given integer by the prime factors. So this can be regarded as a preliminary or auxiliary function. And after that, we do the problem logic. So for those prime numbers appeared or involved in the problem, so we associate them with the corresponding indices, right? And then we use union find operation to examine if they are in the same cluster, right? So this is the problem logic. So with that said, that's basically about it for this video. Thank you.